In this video, we're going to learn how the notation used for line segments changes based on whether we're describing or naming the line segment versus if we're giving the length of the line segment. So we have the same line segment built in bricks here and drawn out here. And the first thing we're going to do is we're going to look at line segment AB, and we're going to give it a length. So when you give a length to a line segment, a diagram, you put that value above or below the diagram. I went ahead and went with above. So let's replicate that in our drawing. So we'll put an 8 here, but yeah, just as valid, you could have put it below the line segment. Let's go ahead and put the lengths on CD and EF as well, those line segments, and put them into the drawing too. So 10 for line segment CD and 12 for line segment EF. We're going to stick to working with these 3 line segments first. Let's give the name of each of these line segments. So AB, and then remember line segments have a bar above, and then CD with the bar above, and EF with the bar above. So when you read this out, that says line segment AB, that says line segment CD, and that says line segment EF. But now say we want to give the length, we want to say that line segment AB is equal to 8. What we do is we do AB, so just the letters, no bar above, equals 8. So that says that line segment AB equals 8. Let's go ahead and do this for CD and EF as well. So CD, just the letters, no bar above, equals 10. And EF, just the letters, no bar above, equals 12. So yeah, when you see the bar above, it's how you name it or describe it in a problem. So a problem could say something like, what is the length of line segment AB? And they would put AB with the bar above to say line segment AB. And then to answer that question, you would just give the value, or you could say AB without the bar above equals 8. Sometimes the question comes up of, how do you know when you only have 2 letters without a symbol above that you're referring to a line segment and not a line or a ray? So remember that a ray goes to infinity in one direction and a line goes to infinity in both directions. Since they have those portions of them that go to infinity, there's no way to have an actual defined length for those. So only a line segment could have an actual value length. So whenever you see just 2 letters equals a number in geometry, that is going to refer to a line segment. All right, let's look at this line segment here. So it has 3 points on it, so it's kind of like 2 connected line segments. So we have line segment GH, line segment HI, and they make up line segment GI. So let's go ahead and write all 3 of those names out. So we have GH, HI, and then GI. Let's go ahead and put some values on these. So GH, we're going to have 7, and HI, we are going to have 12. So let's add these into the diagram. So we'll do 7 here, 12 there, and then let's put these values in here. So we're going to have GH equals 7, HI would be there, and that will be 12. Now for GI, the whole thing, to get that, we would add 7 and 12. So GI will equal 7 plus 12, which equals 19. So adding the portions of a line segment to get the whole thing is going to be referred to as the line segment addition postulate. That sounds kind of complicated, so just don't worry about it right now. We're going to talk about it more and define it in a couple videos. But just know that when we have 2 portions, you just add them to get the whole. Now to label that, what you do is you kind of add a bracket symbol to the portion. So if you have your individual segments labeled above for the whole thing, you would do it below. And then you just kind of make a bit of a bracket here that goes all the way to the ends to indicate you're talking about the whole line segment there. And then you put the value in. And you use those brackets because if you just put the 19, it can be kind of confusing as to whether it's referring to the whole thing or just one of those portions. But yeah, so the big takeaway here is when you're describing or naming a line segment, you use the bar above. When you're given the value, you take the bar off and then put the equal sign in the value. In the next video, we're going to talk about what it means for line segments to be to scale or for them to not be to scale. So if you look at our diagram here, we have EF equals 12 and so does HI, but they're different actual drawn out or modeled lengths. So in the next video, we're going to learn how to handle and describe situations like that.